Good evening, students. So yesterday, we had a lecture. So based on kinematics, okay, and we have touched up all the basics, okay, of kinematics, and now we'll be doing some questions. Some more is left. Some two or three concepts hardly we have. So we'll complete that, and then we'll jump into questions. We have different types of questions, that can come from the kinematics point of view. All right. So with that, we'll begin. So few more topics we'll see. So yesterday we have covered until the graphs. So we have looked at different types of graphs based on kinematic area. So on that we will continue. So let me just get the stylus ready. I hope you guys should be able to see it now. Yeah, I hope it is visible now. Okay, what I'm writing. So we'll now move on. So we can call this kinematics part 2 with today's date. That's 3rd of August. Fine. So now we have learned about the different equations of motion in kinematics, that is popularly called kinematic equations. So we have learned about that. We have seen about the different aspects of physical quantities, like velocity. We have looked at speed. We have even learned about average speed, average velocity, so on and so forth. Okay, until graphs. So this is all we have done so far. Now we are proceeding further with again another small topic which is necessary, which is called as relative velocity. Okay, so we'll be touching that today. So with the next aspect, let me just check on the number. So I think it was 10 or 11. Yeah, it is 12. So this is the 13th concept. Concept number 13, which is relative velocity. Yeah. So what do you mean by relative velocity? What does this term literally mean? As the term itself suggests, that it is relative with respect to a particular frame of reference. For example, if we have two objects that are moving, say object A and object B. Okay, so I have both objects. So let us try to illustrate this scenario. I'm having, say, object A. I'm representing using the dot, which is moving with a velocity of, say, VA. So VA is the velocity of object A, and you can see that it is moving towards the right. Okay. Similarly, we have another object at point B, okay, which is also moving with a certain velocity along the same direction. We can call it VB. So here we have two different objects moving with velocities A and B, as shown here, wherein we have one of them greater than the other. That is, velocity of one object is greater than the other object. So let me assume that velocity of A is greater than velocity of B. So if this is the case, then what is the relative velocity of one object with respect to the other? So we express the relative velocity as velocity of A with respect to object B. Okay, B AB, or you can also put a line to show the difference, to differentiate between both. So velocity of A with respect to object B can be expressed as VA minus V. That is velocity of the object A minus velocity of the object B. So whichever object is moving with a greater velocity, you will first write that particular term and then subtract the velocity of the other object that is moving in the same direction. So relative velocity of one object with respect to the other can be expressed like this. Similarly, you can also find out what is the relative velocity of B with respect to A. You can write it as VBA and you write this as VB minus VA. Simple. So this is how you express relative velocity of one of the objects with respect to the other. Okay, so this is basically the idea of relative velocity. When objects are moving in the same direction, if they are in the same direction, you have to keep in mind you are going to express the velocity of that object minus the velocity of the other object in the same direction of motion. That's how it works. So I'll just write down here for your reference. So VAB, how do you call it? What do you call VAB? You call this as relative velocity of A with respect to B. That's VAB. Okay. Sometimes you can just write it as VAB. You need not show the line also in between. Okay. Sometimes books also refer as VAB. That's also fine. Both are one and the same. Okay. The notation might vary, but the meaning is ultimately the same. Okay. So VAB means, I repeat, relative velocity of object A with respect to object B. And VBA is the other way around, vice versa. Okay. So for example, let us take a scenario. In this case, calculate the relative velocity relative velocity of the bicycle with respect to the car and vice versa. Now the question says you'll have to calculate what is the relative velocity of the bicycle with respect to the car and vice versa. Let us see this. So you have the situation given here as, so I'm giving you the bicycle. Okay, so let me call the bicycle as by a certain point. Let me call this point as B, where B represents bicycle, and bicycle is moving towards the right with a velocity of 5 meters per second. Okay, now this is bicycle. Point B represents bicycle. The direction is given by the arrow mark, as you see. Similarly, you also have a car that is moving, which is given by the point C. This is car. That's also moving along the same direction, but there's a difference in the velocity. So car is moving with a higher velocity of, say, 12 meters per second. That's the velocity of the car. Now in this case, you will have to find out first relative velocity of bicycle with respect to the car, and second, relative velocity of car with respect to the bicycle. VCB, VBC and VCB should be calculated. So how can we calculate VBC? Based on the explanation I gave you before. Anybody, what is the first expression that needs to be written? First term that you will write, velocity of the bicycle. So as per the illustration, velocity of the bicycle is 5, so you need to substitute that first, okay, which is VB minus VC. So 5 meters per second minus 12 meters per second. I hope it's visible to all of you. So now subtract it, and therefore you get the answer. Okay, you just need to subtract the values, and the resultant answer would be, I think some of you are trying to give the values. Okay, you're able to hear? Am I audible to all of you? Yes, somebody is trying to tell something, but I'm not able to see who is that. Okay, I hope I'm audible. Okay, so I think you should be able to hear what I'm saying. So here we are trying to calculate what is the relative velocity of one object with respect to the other. So you have two objects moving along the same direction. So velocity of one object with respect to the other. That is what we are dealing with. Okay, so here you can see B and C are two objects that are moving towards the right. So velocity of one object with respect to the other is what we are trying to find out. So velocity of object B with respect to the object C. So we do Vp minus Vc, which is 5 minus 12. Okay, so you will get the value as 7, right? So you have the negative value, so it's minus 7 meters per second. So you would be getting negative 7 meters per second. So that's how you compute this particular value. So here you have the negative sign also. So keep that also in mind basically. So like this you calculate it. The same way you can also find out the relative velocity of the cycle with respect, the car with respect to the bicycle. CB, C represents cycle, B represents your bicycle, and C represents the car, as you can see here. So let me write that also. Here B is bicycle and C represents the car. So you have both the aspects. So car with respect to the bicycle. So again, it is velocity of the car. It's quite evident. Car value is 12. So 12 meters per second. Substitute minus bicycle value is going to be 5. This time you would get the answer as positive 7 meters per second. So like this, you will get the values of relative velocities of one of the objects with respect to the other. So this is how you calculate the relative velocity of one object with respect to the other. Okay, so that's the basic idea. If they are moving in the same direction, we would subtract. If they are moving in opposite directions, basically we add. Okay, so these are the points that needs to be kept in mind. So I'll give you the other aspect also. Okay, so we'll see. Lesson name, somebody is asking for the lesson name. It is kinematics. Last class I hope you guys would have attended, so you will have a continuation. Okay, it's actually kinematics. Fine, yeah. So moving on. Yeah, fine. If you're not able to understand because maybe last class you didn't attend, so there is a continuation, okay, to the last lecture. So ensure that you're regularly attending the lectures. Okay, fine. In case if you're having a doubt, you can definitely ask. You can unmute and you can ask. Okay, so relative velocity is the concept that we are seeing. Just one last concept. Okay, so here you try to find out velocity of one object with respect to the other. Okay, so that is what is called as relative velocity. Fine. Yeah, so now we are moving on to the next aspect, when objects are moving in the opposite direction. So we'll see that. So relative velocities. So relative velocity of objects moving in opposite directions. Okay, in opposite directions. When you have objects moving in opposite directions, it can be perceived in two different ways. You can basically try to analyze this in two different ways. The first way is when objects are approaching each other this is one. Second is when objects are moving apart from each other. That is second. So these are two different ways of looking at this concept. Second is objects moving apart. Okay, moving apart from each other. So these are two aspects where objects are moving in opposite directions. The first case, they are moving or approaching each other from opposite directions. So it is basically like this. This is approach. And this is basically moving apart. Okay, these two are basically opposite directions. You can see both of them either approaching. You can see that one is moving towards the right, the other is simultaneously moving towards the left. That is, the other case is the opposite of the previous case. Apart and moving together. That is moving in the same particular direction, approaching each other. That is what we are trying to say. Opposite directions, they can come against each other, they can move apart from each other. So these are two different aspects. So in this case, the relative velocity is given by, then relative velocity is sum of the velocities. Okay, then you will add up the velocities. So relative velocity of, say, object A with respect to object B, you just need to add BA with B. That's it. You just need to basically add the values of the velocities of both the corresponding objects, okay, which are approaching or which are moving apart from each other. That's it. So this is how relative velocity typically works for objects in the same direction of motion, objects in the opposite direction of motion. For opposite, now we have learned. For same, we have seen in the previous concept. Okay. So with this, we finish the concepts of kinematics. So we have brushed up with all the basics, and now we can start solving the questions. Okay, for kinematics, we'll see certain questions for your examination point of view. So we'll now do the questions basically. So here we go. The first question. So we'll see exam type questions. So the different varieties of questions. So we'll start with certain simple ones and then we'll move on to complex questions. Okay. Yeah, here comes the first question. Which of the following graphs, or which of the following graphs represent an object in non-uniform motion, So they're asking which of the following graphs is going to represent an object in non-uniform motion. So you have some question figures and then we have the answers. So I'm giving you the question figures here. Okay. So the first figure is given by the Roman letter 1. Okay. This is the second question figure. This is the third question figure. I'll draw it. And this is the fourth one. Okay, so different figures have different meanings. So first one is a position time graph. So this is a position time graph that is there. Okay. Then you have a velocity time graph, and then you have displacement and time graph, and then you have acceleration time graph. Okay, so you have 4 graphs here. One is position time, second velocity time, third you can see there is a displacement time, and the last there is an acceleration time graph. Okay, so here comes the options. Option A, 1 and 2. Option B, 2 and 3. Option C, only 2. And option D, 2, 3 and 4. Okay, 2, 3 and 4. So what is the answer for this question? So you have 4 options. Now based on the graph that I taught, you will have to answer based on the graphs that were dealt in the last class. So which of them would represent non-uniform motion? Yeah. Do you have non-uniform motion graph here or not? Is there any graph that represents non-uniform motion?
No, sir, everything represents uniform motion.
Everything is representing uniform motion. Everything represents uniform motion. First one, you see the first one. First one, object is at rest. Here it is at rest, right? If you try to analyze it carefully. Here, the second one, equal intervals of time, equal, you can see that velocity is going to be equally changing. Gradient, the slope is going to be constant. So this is uniform. Okay. Third one, you can see that equal displacements in equal intervals of time, right? So again, you can call this uniform. The last one, you can see the acceleration is quite constant. The acceleration is constant with time. So that much information you have. So this is also going to be uniform. Okay. So here the question should be reframed. The way they have asked here is wrong. So we'll reframe this. Represent uniform motion. We'll make it. Okay. So they have to make it uniform. Here the question is different in this module. Okay. So we'll change it. So if it's uniform motion, then what would be the answer? So we have to analyze it. Then I think you have a clear picture, right? So now it basically falls into place. So now it is making sense. You can see that 2, 3, and 4. So the answer is option D. Okay, for this. So the module, there is a mistake here. So it is uniform motion, not non-uniform. It is uniform motion. So in this case, you can see the answer is option D. So D is the answer because 2, 3, and 4, all of them represent uniform motion. Okay. So we'll see the next one. Let me just open up a different question. Let's see the second question for the day. Yeah, here's the next question. A body covers a body covers 26 meters, okay, 28 meters, 30 meters, 32 meters in 10th second, okay, in 10th second, 11 second, 10 second, 11 second, 12 second, and 13 second respectively. Okay, so they've given you that a body is going to cover 26 meters, 28, 30, 32 in the respective seconds of 10, 11, 12, and 13. That's what they're telling. Okay, the body starts now. Here the options are there. First option, your option A, the body starts from rest and moves with uniform acceleration. The body starts from rest and moves, okay, and moves with uniform acceleration. And moves with uniform acceleration. That's the first option, A. Second option, it says from rest, states from rest and moves, from rest and moves with uniform velocity this time. Okay, and moves with uniform velocity. Okay. C, with an initial velocity and moves with uniform acceleration. I repeat, with initial velocity, I'm just jotting it down. With initial velocity and moves with uniform acceleration. And the last option, that is D, with initial velocity and moves with uniform velocity racing. With initial velocity and moves with uniform velocity. Okay, so these are the four options. So out of these four, which do you think is more appropriate as per the given situation? A, B, C, and D. So carefully analyze the question, read it. You can see the body is covering 26, 28, 30, and 32 meters in 10, 11, 12, and 13 seconds as per the given question. So which of the option you feel is most appropriate? Yeah, you can unmute and you can say, somebody's trying to answer, but again, I'll have to go back to the screen. What about its corresponding acceleration? Okay, somebody's trying to answer D. Okay, it's actually not D, but it's a good guess, but it's not D. You're near to the answer.
Option C.
Yes, option C is absolutely right. Okay, so it's option C. And how did you arrive at option C? That's correct. How was it option C? Any justification you would like to give?
Because the meter is increased by two values, sir.
Yes, you
And
can
the
see.
second
Huh.
in one increasing, sir.
Correct. Look at the equal, intervals of, the units of distance. You can see, as you rightly said, it is increasing by 2 units. You can see there is an increase, increment. So there is an initial velocity, and it is moving with an uniform acceleration. If you go and calculate the acceleration also is going to be uniform in this particular case. So therefore, the body has some particular value. So there is an initial, velocity associated with the body. That is the reason it is covering 26 meters first itself. Okay, so 26, then 28, appropriately it is changing. So uniformly there is acceleration with some initial, velocity. That is the reason the answer is C. Very good. So it is C for this particular question. Good. Moving on to the next one. Okay. Question number 3. So let us see question number 3. Okay. Now here, this is, based on the graph. So you will have to calculate it. Okay. So I'm giving you the graph now. Determine, the question goes like this, determine the displacement and distance traveled by the body. Determine the displacement and distance traveled by the body. Okay, traveled by the body in 6 seconds. Okay, in 6 seconds. They're asking displacement and distance traveled. Now let us see the graph. I'm just giving you the graph. So this is the graph that is there. Okay. So there is, basically a velocity time graph that is given. You have velocity in meters per second. and then you have time in seconds. Okay, so you have this. So here comes the graph. So let us mark all the points. Here you have the origin. Okay. So say 1, 2, 3, 4. You have positive values on the top and negative values at the bottom, as you can see. Okay, so here is the graph. It's a straight line like this. It forms a figure, symmetric figure. Yeah. So this is the complete graph. Okay, so it starts from 4, then it's a straight line, and then it intersects the time axis at 2, and until -2 again it is parallel until 4, and then it is again intersecting at 4, and so on. It goes like this. This is the graph, children. Okay, so you should calculate what is the displacement and distance traveled by the object. Okay, so that is a question. So I'll give you the options. Okay, uh, so here are the options. So I'm giving it on the right side. So say first option A, 8 meters, comma 16 meters. Option B, 16 meters, comma 8 meters. Okay. Option C, 16 and 16. And option D, 8 and 8. Yes, these are the options. Okay, which is displacement and what is the distance traveled. So you'll have to compute what is displacement followed by the distance traveled. That is what you should do. Now you tell me, how do you find out the displacement and distance traveled from a velocity time graph that is given here? By using the concept of slope, just think whether you will be able to find out what is the slope of a velocity time graph give you. Try to analyze like that, and then you will have to think. Okay. Yes, just try out. So try this question and tell me which is the right answer for this. So you will have to compute the value from the graph. So this is graphical interpretation. Yeah. So you will have to find out. So first bifurcate the given graph into different regions. That is the first and foremost thing that you should do. So here our graph clearly starts from point 4. That is your starting point. Okay. So say this point is A. This point is B. So try to mark it C, D. Say this point is E. This point is F, G, H, and finally you have I. So there are different points associated with the graph. Okay. So once you have identified different points associated with the graph, then you can easily calculate. Okay, good. Some of them are trying to answer. Very nice. Then, okay, some of you are trying to give the answers. Okay, fine. You say it is B, all of you. One of you saying B and said B. Okay, we'll check. Okay, yeah, we'll check that. Fine. So now, how to calculate it? Now look at the first region. Okay, the region AB. Okay, that is ABC. This particular region itself, if you take, you can see that there is a figure that is formed. You can see that it looks like a rectangle, right? So therefore, area of a velocity time graph will basically give you the displacement. So keep this in mind. Area of velocity time graph indicates displacement. So find out the area first. Okay, the way it is represented. Okay, So full area of the velocity time graph you will have to calculate. So when I say area of the velocity time graph, you have to keep in consider the areas of all the figures that are given in this particular graph. So how to find out the area of the first figure, which looks like a rectangle? So let me just highlight it for for your understanding. So this particular area. So find out that area first. Okay. So area of the first region. Area of region 1, first region. You can see it is length into breadth, right? So what is the length? Length is the time axis, which is, you can say it is looks like 2 seconds, but you can take the other parameter as the length, which is 4 meters per second. So first region, it is 4 meters per second into 2 seconds. So second and second will get cancelled. So 4 twos are, you will get 8. Okay, 8 meters. That is first area of the first region. Now area of second region. Coming back to the graph, the second region area, look at the length and the breadth. Okay, so 4 minus 2 is your length, which is 2, and the breadth is also, you can see here, the breadth is basically, that is also going to be 2 units. But where is the 2 units? The 2 units is basically on the negative x-axis. Okay, the negative value, because minus 2 it tells. So you have to write it down. So it is 2 into minus 2, which is minus 4. Okay, 2 seconds into minus 2 meters per second. So second cancel, you will get minus 4. Minus 4 meters. Same way, area of region 3. You calculate that also. Again, you are going to get minus 4 only, right? Because it is again 2 meters per second into, minus 2 meters per second. Will you say minus 2 meters per second? Because it is on the positive side, not minus, plus, right? Because it is above. So you will get this time same value, but the positive side, which is plus 4 meters. How plus 4 meters? 2 meters per second into 2 seconds. You're getting it? Because 2 meters per second is above the x-axis. Something above the x-axis, positive value. Below, you will take negative value. So this is 2 meters per second into 2 seconds. Second cancel, you will get 4 meters. So now, if you find out the total displacement. The total displacement is sum of all the 3 regions, 1 plus 2 plus 3. So you add everything, 8 plus 4 minus 4 will give you 8 ultimately. So 8 meters is your displacement. Okay, so displacement, if you see, it is 8 meters. Fine. Now we need to calculate what is the displacement. The distance traveled. Displacement is done. Distance traveled we have to calculate. When you calculate distance traveled, I told you, distance traveled is the total path length traveled by the object. Okay, irrespective of which direction it is going to travel. So distance traveled from the graph, if you have to find out, is nothing but the total path length. Now here you will not consider the negative signs. So basically you will take the modulus of sum of areas. Very important. Sum of areas, you will take modulus. Okay, what do I mean by modulus operator? It converts everything into positive. So when you take modulus, it is mod 8 plus mod of minus 4 plus mod of plus 4. Therefore, you will be getting 8 plus 4 plus 4. Okay. So how much is the answer? You will get the answer as 16. So 16 meters. So displacement is 8 meters, but the distance traveled is 16 meters. So it's actually 8 and 16 in this particular case. And the answer is option A. So A is the right option for this particular question. So this is how you will approach this question. Okay, it may seem to be easy, but still there is a catch. So when it comes to displacement, you have to consider the direction. When it comes to the distance traveled, direction is not necessary. You take just the mod of the entire graph, the area, mod of the area or modulus of the areas to be considered, and then you will add them to get the total distance traveled, and therefore you get the answer as option A. Okay, that is how you do it. Okay, now we'll see another model also. This is one aspect of the question in the in the form of a graph. Okay, there are different aspects also. Okay, we'll see them as well. Okay, so I hope this part is clear to all of you. So with that, we'll move on to the next part of the question, the next type of question. So question number 3. Okay, so we'll see question number 3. This is an interesting question. So if you understand the scenario, this question is going to be easy for you. So here we'll see. The question goes like this. Sania is riding on a giant wheel Okay, Sania is riding on a giant wheel as shown in the figure below. Okay, figure below. The radius of the wheel is x meters. The radius of the wheel is x meters. Okay. A distance time graph is plotted as a function of time. A distance time graph is plotted as she starts. Okay, we'll put it that way, as she starts from point A. Okay, a distance time graph is plotted as she starts from point A. Identify which of these graphs represent her motion. Identify which of these graphs represent her motion for 3 revolutions. Which of these graphs represent her motion for 3 revolutions. So you'll have to identify which of the graphs are representing her motion for 3 revolutions. So here is the figure. I hope all of you know how a giant wheel looks. Okay, so what I'm drawing is a rough diagram. So this is a giant wheel, and it is fixed at this particular point. Okay, and the radius is given. So this is the radius. It is given as x. Okay, that is the radius, and the giant wheel is placed on the surface of the ground like this. So this is the ground level basically. Okay, this is the ground level. So Sania is starting from point A. So the point A is this point. This is the reference point A, bottommost point. Okay, and this is the highest point. Highest point is point B. Okay, so the giant wheel is going to rotate. It is rotating in a clockwise motion as shown in the figure. So it goes in a clockwise motion. Is that clear? So she is riding a giant wheel. She starts from point A. The radius of the giant wheel is x. I am explaining the figure, and she is moving in the giant wheel, and it is covering 3 revolutions. So from the start, 3 revolutions is what she is covering in the giant wheel. So given this scenario, you will have to identify which of the graphs will represent her motion for 3 revolutions. Okay, so we'll look at it. I'm giving you the options now. We'll see how many of you are able to correlate with this and give me the answer. Okay, first option. So distance time graphs is what they have given. Okay, option A. So this is option A. So you have distance here and you have time here. Distance along x-axis and time is basically along y-axis. Okay. Okay. So you have a graph like this. So this is the first graph. Okay, the way it is expressed is like this. This is the first graph. Moving on to the second graph. B. Again you have distance and you have time here also. This is the second graph. And next moving on to the third graph. Okay, which is C. Right this side. So again you have distance, you have time along y and x axis, and here is your third graph. Okay, this is the third graph, and last fourth graph is this. Okay, this is the fourth graph. Okay, so this is the fourth graph. Fine. So which of these graphs represents the motion of Sanya on the giant wheel for 3 revolutions? Is it A, is it B, or is it C, or is it D? So which of them represents her motion and why? Yes, anybody? You can try it. Okay, just analyze the given case. I'll reduce the font size so that you're able to see the graphs. Okay, so you have to analyze the motion of Sanya from point A to point A again after 3 revolutions. Which of the graphs represent her motion for 3 revolutions is what you will have to analyze in this case. Yeah, anybody with any answers, you can just start answering. In case you're confident of any answer, you can tell me. Even otherwise, you can give it a try. Fine. So here you have to carefully see the situation and then tell me. Yes, anybody would like to try? B. Okay. One of them says it's B. Fine. Anybody with a different answer? Pardon?
Option A, sir.
Option A. Okay. No, it's not option A. And yeah, I'm sorry, it's not A. It's not B also. Okay. Yeah. Okay. So the answer is C actually. Okay. The answer is C. I'll explain why it is C and how it is C. Okay. Now, if you see, all of you are going to see this particular graph. Okay. So let me just zoom in. Okay. Now here, first I'll show the giant wheel from, we'll start from there. Now Sanya is starting from point A, accepted. From here, she is moving 3 revolutions, right? Now here, look at this. Don't you see that there is a visible gap between the ground and the giant wheel? Can you see there is a gap? This is the gap, which means as she starts her motion, you already have some distance from the ground level. Yes or no? That much is clear. She is not starting from the ground as such. She is at a certain height above the ground. So always your ground is your reference point. When I say origin of a particular graph, it is from 0. But here, her origin is not at 0. It is at some particular point. Okay, you're able to understand this. So therefore, the graph of Sanya will not start from origin. So there itself you can eliminate. So we go by the method of elimination. A is not right. It starts from origin. Look at B. B is also not correct because B also starts from origin. So there itself you can eliminate A and B. Okay. So whenever you have questions, in competitive exams, one of the best methods are methods of elimination. So you will have to be very clever in eliminating the wrong answers, because given the case, you can see that Sanya does not start from origin. She is starting at certain height from the ground level. There is a certain height from the ground level. So there itself you should understand the graph will not start from the origin. The graph will start at a particular value itself. There is a particular value, so it will start from that particular value. So you can see that options C and D, the graph starts from a certain point above the ground level and it makes sense. Okay, so graph C and D makes sense. Now you will have to find out which of them out of C and D is most appropriate or most correct. Are you getting me? Now let us see which of them is most correct. Now as Sanya starts from point A and the giant wheel is going to move, okay, now she is moving from point A to point B. Now what happens as she is moving from point A to point B? She'll move here, she'll cross these points slowly and eventually, and she will reach point B, right? So A is the lowest point and B is her highest point. So lowest point is A. Now both the graph has got some lowest point above the ground level. That is okay. Now as she starts from point A, now what is happening to her distance? The distance is basically increasing, right? So it is increasing from point A to point B. So point A, as she is moving to point B, you can see that her distance is gradually increasing. So how it is increasing is what you should see. Whether it is going to increase like this or it is going to increase like this. Okay, so that is what you should understand. Now she is in circular motion. So Sanya is moving in a circular path, which means she is in a circular motion. Like this she is moving. And she is reaching a point. So from A to B, she is moving. She is not moving from A to B like this. She is not going up and then coming down. Had she been moving up and coming down, then you can say that D is correct. Uniformly, she is moving. But this is circular motion. Whenever you have circular motion, the movement of the object in a circular motion is going to be a sinusoidal motion. Sinusoidal motion in the sense gradually it increases, like a sine curve. So it increases, reaches maximum point. So this is point B, and then she will again decrease from point B as she comes to point A, gradual decrease and comes to point A. Again she reaches highest point, point B for the second revolution. First revolution, from say this particular point. So let me call this particular point as A. So from A she's reaching to B and then back to A, first revolution. Again A to B and back to A, second revolution. So A to B and back to A, third revolution. So like this three revolutions Sania is trying to is basically covering in a circular path. She's not just moving up and down like a lift. It's not like a lift. It is a circular path. So therefore gradual increase, gradual decrease. So there is a increase. It's basically a sinusoidal curve. So it's a sine graph. So D is not a sine graph and D is wrong. So the answer is C. C is the most appropriate answer. Okay. So that is the answer for this question. Okay. So the answer is option C. That's how you will approach this question. So this question is based on a real life example. You see how the question is now mapped? The question is mapped to a real life example, and then the graphs are being framed. Okay, this is how you will have to put yourself there, and then you will have to think and carefully analyze before coming to a conclusion. All right. So that's how you need to solve this particular question. Okay. So the answer is option C for this question. Is that clear? So that is what it is. Okay. Simple. So the distance x, what is given by the distance x? It is the distance between point A and point B. If you're going to draw the line between A and B, that will be the distance x or 2x. You should be careful because as she moves from point A to B, you can see the distance between point A to B is going to be twice the radius, which is the diameter. So it is 2x. So that is 2x basically. So the distance between A and B is not just x, it is going to be 2x. This distance is 2x. So that is the distance between the peak, the point B, to the initial point A from where she starts. Okay. So the height of the peak is 2x. That also you can calculate from the given situation. Alright, sometimes questions they can ask that also. What is the distance between the peak to the initial point A? Okay, given the data. Fine. So with that, we'll move on to the next question. So this was, a tough one. So where you will have to analyze and then answer. Okay, interpretation of the data is what they are looking for. So how you interpret the given data and how you try to illustrate it. Okay, so your interpretation and illustrational skills are basically tested here in this question. So with that, on that note, we'll move on to the next one. It's a beautifully designed question. So we'll move to the next one, question number 4. So we'll see the next question. Yeah, here's the next question. I'll just write it down. The distance traveled. Okay, the distance traveled by a particle. The distance traveled by a particle starting from rest. Okay, starting from rest and moving with an acceleration. Okay, and moving with an acceleration. Moving with an acceleration of 4 upon 3 meters per second square. That is 4 by 3 meters per second square in the third second. In the third second is. Okay, in the third second is. So options, let's look at the options. First option, 10 upon 3 meters. Option B, 19 upon 3 meters. Option C, 6 meters. And option D is 4 meters. Okay, they're asking you what is the distance traveled by a particle starting from rest and moving with an acceleration of 4 by 3 meters per second square in the third second. So they're asking what is the value for the third second they're asking. Yes, anybody can tell me what's the answer? An application of equations of motion. Yes, chill. Just try this out. So work it out. Have a notebook. So when you're solving questions, it's a good practice to have a book. So try it out in the notebook. Do a rough work, and then you can tell me the answer. Okay, please don't take guesses, because usually such questions, making guesses, you will go wrong. So it's better that you solve it and then you get back with the answer. Somebody's trying to answer. Let me just check. What's the value? Okay, A. Fine. You're saying A. One of them is telling A. Okay. Anybody else with a different answer? Everybody stick on to A. Yeah, all of you agree with A? Okay, fine. So one of you are telling A. So how do you arrive at A? What is the explanation? Yeah, you said it is A. So how do you arrive at the value A? Yes, that's fine. That's correct. But the method of solving the question is what I'm looking for. The different ways of solving it, approaching this question. That's the reason I'm asking. Okay. So here, the distance traveled by a particle starting from rest, they are clearly specifying that it is starting from rest and it is moving with an acceleration of 4 meters per second square. Okay, acceleration is given. They are asking in the third second. So when they are saying in the third second, you need to consider the distance traveled by the object in the second as well to compute your value. So usually what we do, we generally substitute and we think the answer is 6. If you're doing a direct substitution, you will be getting 6. But that is a common misconception. So whenever you have questions given like this, carefully write down what is the given data. Initial velocity is 0. Okay, u is 0 meters per second. Okay, so you're trying to calculate what is the distance traveled in the third second. So when you try to find out what is the value in the third second, then appropriately you will have to find out the distance traveled by the object in the third second first. So S for the third second, I told you nth. Sn, I gave you a formula. So use that particular relationship first. So make use of that particular relation. So what was that particular relation? If you can recall, I gave you the formula for Sn. So make use of that, expression. So let me write down here. Distance traveled in the third second is, can I express this as distance traveled in third second minus distance traveled in the second second. So distance traveled for the third second minus the distance traveled during the second second. That is in the second, for 2, you can say, when t is equal to 2. So I'll just put it that way so that it is simple. When t is equal to 2. Okay, t is equal to 3 minus when t is equal to 2. So as initial velocity is 0, so go and substitute that particular value. Okay, so when I substitute that particular value here, you will get, by the relation I have taught, it is 1 by 2 a, which is acceleration, into t squared. Okay, so t squared minus, again, 1 by 2 a into t squared. So let me take it as t1 and t2 to differentiate. So T1 is 3 and here T2 will take it as 2 seconds. So going and substituting the values and simplifying them, you will be getting the value as 1 by 2 times A is common, A is acceleration term. So you will get T1 square minus T2 square. Substitute third second and second we are saying. So it's 1 by 2 times A. So substitute the value. So it is 3 squared minus 2 squared, which fetches you half times acceleration into 3 squared minus 2 squared. You compute the appropriate value. So 3 3s are 9, 2 2s are 4, 9 minus 4 will give you 5. Okay, half into A into 5, where A is acceleration. So now go and substitute the value of acceleration that is given in the question. Okay, which is 4 upon 3. So go and substitute the value. Okay, which is 4 by 3. So substituting the value of 4 by 3 and 5. So you get the answer as 2 2s are, so 2 5s are 10. So you will get the answer as 10 upon 3 meters. Okay, so that is the value. In decimals, if they are giving, it would be 3.33 recurring. Okay, so 10 by 3 is there. So the answer is 10 by 3, and that is option A. That's right. What you said is right. But that how you solve it, this is the method of solving. Distance traveled when t is equal to 3 seconds minus the distance traveled when t is equal to 2 seconds. Both you will have to subtract, and then you will find out what is the corresponding value for the third second. So like this, that is what is meant by the two consecutive values. So 2 and 3. So the preceding value is 2. So 2 and 3 to be kept in mind. Same thing if they ask fourth second, you know now how to generalize, right? If they ask you for the fourth second, a simple modification. So here you will do 4 minus 3. That's it. That's how you will do. Okay. So that's how such questions to be approached. Okay. Well, let's move on to the next question. So question number 5. We'll see the next question, children. So here's the next question. So let me just write it down. It's quite a big question. So a particle moving with uniform acceleration, a particle moving with uniform acceleration, a particle moving with uniform acceleration has velocity of 6 meters per second. Has velocity of 6 meters per second. Okay. At a distance 5 meters. At a distance 5 meters from the initial position. From the initial position. This is the first part of the question. Okay. The question continues. After moving another 7 meters, the velocity becomes after moving another 7 meters, the velocity becomes 8 meters per second. Okay. The velocity becomes 8 meters per second. The initial velocity and acceleration. The initial velocity and acceleration of the particle. Okay. Of the particle are so here you have the options. So option A, 2 meters per second and 4 meters per second squared. Option B, 4 meters per second and 2 meters per second square. Okay, option C, 4 meters per second and 4 meters per second square. And option D is 6 meters per second and 1 meter per second square. These are the options. Okay, read the question carefully. So I'll explain the question again for you. A particle is moving with uniform acceleration, they're telling, and it has a velocity of 6 meters per second at a distance of 5 meters from its initial position. Okay, this is the first part. There you're having two datas. Similarly, the second part is also having two datas. It is moving another 7 meters. Further, it is moving, and then the velocity becomes 8 meters per second. So given these two cases, they are asking what's the initial velocity and the acceleration of the particle. So that's the question. What's the initial velocity and the acceleration? Yeah, any answers you can let me know. Okay. So which particular relation we can use here? Which would be more apt, okay, to solve this particular question? So you will have to first think in that direction. Yeah, anybody is having any answers? If you have tried, you can let me know. Okay, appropriate. Feel free to ask. Feel free to unmute and ask in case you have any queries, or you want to answer also. You can unmute and you can answer. Okay. Because each and every time I'll have to go back to the screen. That's the reason, to check what comments you have written. So that becomes tedious. So it's better that you can unmute and you can check. Yeah, any answers? I hope you're trying. I'll give you another minute. You can try.
Option B, sir.
Option B, okay. 4 meters per second and 2 meters per second square, right? Yeah, that's right. You're absolutely right. Good job. So the answer is option B. Let us see now how it is B, okay? So you might be eager, some of you. I hope some of you have tried and you have got the answers. Very good. So we'll see how it needs to be solved, this particular question. Okay. Here, this question has, two different sets of data. Okay. So there are two different aspects to this particular question. Now, we'll go one by one. Okay. On the first part, what they have given in the first place, they have given you the velocity 6 meters per second and they have given you a distance of 5 meters. Both have been specified here. Okay. So here in this particular aspect, now if you're going to substitute the particular value, so you can use equations of motion. Okay. So you can say v square minus u square is equal to 2as. Why I'm using this third equation of motion is because nowhere we have the information about time. Okay, the information about time is not specified to us anywhere on the question, so you don't have information. So better to use the equation that is independent of time, which is third equation of motion, which tells v squared minus u squared is equal to 2as. So this is the equation, best choice to solve this question, because the question is not specifying time anywhere. So time is not known to us. So in such a situation, it is better that you write an equation that is independent of time. Okay, so better you express in independent of time equation. Now let us go and substitute, okay, in this particular data. So here, now moving on with this equation. So you go and see here, they're telling 6 meters and it is covering a distance of 6 meters per second, and they are telling it is 5 meters. Now what is 6 and what is basically 5? Okay, so that is the initial velocity. A particle moving with uniform acceleration has a velocity of 6 meters. So they are specifying that 6 particular meters at a distance of 5 meters. Now instead of taking this as 6 for this particular case, we are not sure whether it is started at just 6. It could have started at some other value also. So better to now go to the second part of the question. Second part, we are having some clarity. They're telling after moving another 7 meters, Now the velocity becomes 8 meters per second. Now here you have some information. This is the second case. So you can now with certainty you can say your final velocity is 8 meters. Are you understanding? 8 meters is after some time. Before 8 meters per second it was 6 meters. That when we know for sure. So therefore my initial velocity is going to be u is 6 meters per second, and then final velocity will be 8 meters per second. So like this, you first identify the given data and then you go and substitute in this particular formula. So going and substituting here, you have the particular value for acceleration. Okay, so I am writing the equation in terms of acceleration. Rearrange for acceleration, children. Okay, so when you rearrange this for acceleration, you will get acceleration as v squared minus u squared upon 2s. This is what you will get. Okay, go and substitute it and simplify it. V squared is nothing but 8 squared. So 8 squared minus 6 squared. Okay, so you have 8 square minus 6 square upon 2 into what is the value of s. Okay, because you have the value of s as 7 meters. You will not take 5 meters. You should be very careful. So it is 7 meters because that is where the velocity is changing. For the next 7 meters, they are clearly specifying after moving another 7 meters. So it's clearly specified in the question. So you will take s as 7 meters. So 2 into 7. Simplify acceleration. 8 square minus 6 squared upon 2 into 7. 2 sevens are anyways 14. So 8 square minus 6 square. You can use the algebraic identity. It is of the form a squared minus b squared. So it is a plus b into a minus b. How much is a plus b? I hope you guys know. Right? 8 plus 6, which is 14. Right? So 14 into 8 minus 6 is 2. Divided by 2 sevens are 14. 14 cancel direct. You will get the answer as 2 meters per second square. Is that clear? So here we have calculated the acceleration. So acceleration is 2 meters per second square. That's the value of acceleration. Okay. Now go with the elimination method. You see which of your options is having 2 meters per second square. It is only one option. All other options have different values. Correct? Sometimes if there is a tie, in that case you will have to solve the other part also. Okay. This case it is directly evident that 2 meters per second square is only appearing for option B. So you can save time. You need not solve the other part. I mean, for this case I am saying. Okay. But this might not be true for all the questions. Certain questions you will have similar answers. So elimination method might not work for all the questions. Okay. Second part, if you are going to solve, now let us see how to find out the initial velocity. Okay, u, how to find out u. Okay. So again, you want to find out u, rearrange this equation for u, children. So take your u for one side, make it positive. So can I write u square is equal to v square minus 2as? Correct? We can write it that way. Okay. Now go and substitute the values and find out what is the value of u square. Okay. So you will get u square as, again. So substitute the values here. What happens to the value of u for value of v? You will substitute which particular values? You have two values. One is 6 and one more is 8. So you will substitute here 6 and not 8. 8 is for the other velocity, other part, right? So you have to substitute 6 in this case, not 8. That also you should be very careful. So substitute the value as 6. So 6 squared minus 2 into acceleration is also going to be 2, and the distance that it is going to travel. Okay. So how much distance it has traveled? It has traveled a distance of 5, right? So 5. So 2 into 5. That is for the initial case. So simplify it. So you will get 6 square as 36 minus 2 to 4. 4 5s are 20. So 36 minus 20. You will get the value as 16. Okay. So u square is 16, which means u is going to be under root 16, which is 4 meters per second. So you get the initial velocity as 4. So 4. So that makes sense. Option B is right. So it is 4. So like this you will have to calculate. Okay, so carefully you should analyze the question, and then you will have to solve this based on which equation of motion would be a wise choice. You should wisely choose which equation is a perfect fit to solve this question, because nowhere time is given. So it's better that you choose time independent equation of motion, which is the third equation of motion, the third kinematic equation. Am I clear? So like that you will use the third equation, and then you will solve it step by step. Okay, and then we found out what is acceleration and velocity. Okay, the initial velocity. Fine. So that's how you need to do, children. It might seem simple, but this requires practice. So ensure that the same questions you're practicing and getting the answers, so that your confidence level will boost, and then you can try different types of questions. Okay, so any queries you can ask. Okay, the forum is open for any doubt clarification. You can ask if you have any queries or doubts. Okay, I'll share the PDF.
Thank
For
you,
your
Manish.
reference. Yeah, welcome.